we learned about the page replacement algorithm. There are several page replace algorithms. Already you learned about that contiguous, non-contiguous memory segmentation, paging, then logical address, physical address, segmentation, and lots of. Today you learn about that page replacement algorithm. You know, whenever a process is run, only at that point of time page is created, otherwise there is no page is created. That is the major important thing. So page replacement algorithm decide which memory pages to page out. Sometimes that is called swap out or write to disk when a page of memory needs to be allocated. Page replacement algorithm means when you are run your process, at that point of time, your processor actually decided that for that process whether it need to write the page or not, and if it write the page, so in the memory allocation which memory block or which address it will write the page table. So whenever it write the page table in the memory block, that means your computer or your operating system must be need to release some space to write the page. Otherwise, if the computer memory is too much full, say for example, your computer main memory is 5 kilobytes. Now you want to run the process and your 5 kilobyte main memory is already filled up. So now at that point of time, how can you run your application, your create the page table? You need to make to some space to clear it and you can write it. That is called page replacement algorithm. That you make some space for your page. Now page replacement happen when a requested page is not in memory and a free page cannot be used to satisfy the allocation, either because there are none or because the number of free pages is lower than the threshold. Now, this sentence is meaning that already when your process is run at that point of time, page table will be created. After complete the running of the process, page table will not be removed from the main memory. It is actually stay at there. So whenever I again run that process, at that point of time, your processor don't need to create page table again. If I run the same process again and again, but I want to run the different process from my page table again, the different process. At that point of time, what will happen? At that point, it will remove the previous page table and it will create the new page table as the new process is running. So that is actually at that point of time page replacement is happen. So for page replacement there is four types of algorithm: first come first out, optimal replacement, least recently used replacement, and most recently used replacement. So all of these algorithms I will discuss in this chapter with you. So guys, in this slide, if you have any question you can ask.
Ma'am, I want to go to take corona vaccine. Today is my scheduled date. Can I
I
leave the
don't
class?
I don't get you. What are you saying? Please repeat it again.
ম্যাম আজকে আমার করোনার ডোজ নেওয়ার কথা ম্যাম, ভ্যাকসিন নেওয়ার কথা, দ্বিতীয় ডোজ আমাকে
Oh,
মেসেজ
okay.
করেছিল।
What is your serial?
ম্যাম 28।
Okay, you can leave. Okay.
থ্যাংক ইউ ম্যাম।
first in, first out algorithm replacement. Now come about first in, first out replacement. So F1 is your first page table, F2 is your second page table, F3 is your third page table. So in here you can see this number, that 72400, it's these numbers are given according to the frame norm, that which frame norm this first process, second process, third process are using, which frame norm these are using. Now at the exam time I will provide you this table with the value of this frame norm, and the important thing here, you can see the star mark and the heat options. So now if I go for that total heat, so total heat is 1, 2 and 3. Total heat is 3, and total page fault. Page fault means that how many pages that it need to be rechanged or it need to be exchanged. That is called page fault. Page hit means only this column, this column and this column. Only these three columns page value can be used again and again. But the other star mark columns page value, it need to be changed. That is called page fault. So total page fault is 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now you have to find out page hit ratio. So total how many pages are there? Total row, how many rows? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. The total is 15. You have to take the highest possible number of rows, not the lowest possible number. You must have to take the highest possible number of rows. So which is 15. So 3 by 15 is 20%, and 12 by 15 into 100 is 80%. So this way you have to find out the heat ratio and the fault ratio whenever it is first come first out replacement. So what happened in first come first out replacement, which is that the process that is come first, that process page will create first, the process that will come last, that process page will create last. So guys, in this slide, if you have any question, you can ask. Okay. Now, optimal replacement. All of these types of algorithms, the four types of algorithm, that first come, first out, then optimal replacement, then least recently used, then the most recently used. All of them. In the algorithm, you have to find out the page hit and page fault. So, from the table, at the exam time, you get down the what are the hit you get and how many fault you get. And from there, you can find out page hit and page get. in first come first out, you have to find out the reference string. Now what is actually your reference string? Reference string is represented that which page number you need to change. So it is follow the first come first out. So first come your 7, then go for 0, then 1. Like this way. 7, then 0, then 1. After that, you need to replace. Already I have take 7. Now I have to take 2. Because after 7, 7 will not replace. Because at the next time, whenever your page will created, you need to use 7 automatically. So 7 will not replace. You will go for 7 again. So then the reference state will be 2, then it will be 0, and after already I have take 1. So I will take 3. After taking 3, then I will again go for 0, and after that already I take 7, 0, 1. This first block is complete. After complete the first block, then I go to 0. But already 1 is given in here. So I don't go for 1, I go for 2, 0 and 3. After taking 3, my block of 1 is complete. 3 I have already taken. So I don't take this 4. So I will go for 4, and again inside the up I need to take the 0. So 4, 0, and after I will take the 2, then I will take 3, then I will take 0, I will take 3, then 1, then 2, then 0. So what just happened in here, if I draw it like this way, that what just happened. First I take 7, then I take 0, then I take 1. And now the thing is that after that I will go for 2. So 2, then 0, then 3, then 0, 4, 2, 3, 0, 3, 1, and at the end 2. Now actually what is happened in here, first I will take the value 7. After taking the value 7, then easily I go for the process 2, which is take the 0 first. Then I will go for process 3, which is take the 1. So this is the easiest way how I can take 701. Now the thing is that which value I will take for replacement. Already you can see that 7 is happening here again and again. 0 also happening here twice. 1 also happening here twice. So the new after 7, the new thing which is come, that is 2. So I will go for 2. So after 2, if I go to the second column, which thing I can take? So after 2, I need to take 0 again, because the new page table at that point of time the heat is 3, So maximum 3 times you need to stay with 0. But whenever it is about the more than 3 times, because it is 3. When it's about more than 3 times, I need to take the same value again. So it is come about fourth time or fourth place, this 0. So I take this 0, then the new value which is come, that is 3. After 3, then again in the, because I take these two things from this second position, I need to take also from the third process. So from the third process, I need to again 0, because this 0 is again come after the fifth place. So I take this 0. After 0, then which value is come new at this first process, that is 4. So I take 4. In the second process, which value come after 3 new, that is 2. So I take 2. Then at the first place after 0, which value come new, that is 3. So I take 3. So after that I will again take 0. Then which value come new, that is 2. Then 3. Then 1. Then 2. So like this way the reference string is happen in here again and again. So guys, in this slide, if you have any question, you can ask. Now come about the algorithm, which is optimal replacement algorithm. So replace the page which is not used in longest dimension in time in future. Means I will replace the page that is not used for the longest possible time in future. So I have a several application softwares in here. So say for example, today I run virtual memory or the virtual box. After run today the virtual box, then I did not run the virtual box for 1 week, 2 week, 3 week. At that point of time, the processor will replace the page of the virtual memory with the process that is run regularly. So replace the page which is not used longest dimension time in future. Means in future the page that not run for the longest possible of time. So already I gave you the heat number, that is 12, and page fault which is 8. So by this way you can get out the page heat and page ratio. Now the reference system, which is first 7012. The first possible 4 values I take. Then after that I take the 0304. That means that which page I will actually changes in a sequential order in this table. Now the thing is that in the optimal replacement, that is representing the table that will not run for our longest possible time. So firstly, if I draw, I take 7, 0, 1 and 2. So these 4 references is the easiest way that how I can get or how I can take it. After that 0. Then I take 0, 3, then 0, then 4. After that, I take 2, then 3, then 0, then 3, then I take 2, I take 1, I take 2, I take 0, I take 1, I take 7, I take 0. Now, what is happening actually in the reference history? Whenever first I write down 7, 0, 1, 2. So, if you see the process number, that from the first process in the table, it take which page number? It take page number 7, 3 and 7. Only this page number. Whenever I go to this process 2, it take page number 0, only the 0. Whenever I go for process 3, it take page number 1 and 4. When I go for the process 4, it take only the page number 2. So the first option is always configure the process 1, 2, 3, 4. The first 4 processes it takes. After that, it will go for this process 0. Now it will replace the process 0, then it go for the process 3, then it go for 0, then it go for 4. After that it go for 2, then it go for 3, then it go for 0, then it go for 3, then it go for 2, then 1, then 2, then 0, then 7, then 1. That thing what is happening actually, that reference string is represented that which page number your page table it will hold in your processing. So the page table that will run regularly, it will hold only the page number for this page table. Other number it won't take it, because the other numbers in the page table that will not run regularly. That is happen in optimal replacement. So guys, in this slide or after this slide, if you have any question, you can ask. So guys, there is a problem in the attendance system. So I have checked who are attend today's class. So guys, I will give all of you attendance later on. I already remembered who are attend today's class. So guys, all of you can leave the classroom. That's all for today. Thank you guys. And
Okay, ma'am.
also within this week, I will at the Google Classroom give your oral exam schedule according to your serial wise. Your oral exam will be held on your session is 22nd of September from 1:30 p.m. to 4:30 p.m. I will announce it at the classroom. So guys, that's all for today. You can leave the classroom.
Okay, ma'am. Assalamu alaikum.
Alaikum assalam.